Welcome you all to this course, Digital Human Modeling and Simulation for Virtual Ergonomic Evaluation. Now, today is the second module for week 2, use of percentile, anthropometric and biomechanical data for product or any other facility design. So, last we discussed about introduction to ergonomics. Now we are going to discuss about anthropometry and biomechanics and different types of anthropometric and biomechanical data, how those data are used in different types of products or facility design. So now this module 2. So before going to discuss about anthropometry, biomechanics or anthropometric and biomechanical data, it is better to study a little bit about basic statistics, which are very much essential to understand what is percentile, what is mean value, what is standard deviation. If we understand these basic concepts of statistics, then it will help us to understand that how percentile anthropometric data or biomechanical data can be used for different types of facility design. So first we start with percentage. So what is percentage? All of you know. Okay. In the class, student may ask, okay, you got 40% marks or 80% marks. Then what does it mean? 80%. You got 80% marks mean out of 100 you got 80. If your exam is in 50 marks, then out of 50 you got 40 marks. If you calculate it, then what is out of 100? Then out of 100 it is coming 80. So percentage can generally be described as or defined as a number or ratio expressed as a fraction of 100. Generally it is denoted with this sign, percentage sign. The word percent comes from Latin word percentum. What does it mean? That it means 100. So already, as I mentioned, in this way percentage is calculated. Now you got out of 50 40 marks, and after calculation we can say you got 80% marks. But in your class your marks is such that your rank in the class is, say for example, I am telling 70th percentile. So you got 80% marks, but your rank in the class based on that marks is 70th percentile. So what does it mean? Percentage is something different and percentile is something. So now to understand that, if we look at the definition of percentile, percentile is the value below which certain percentage of data falls. So say for example, if we ask all the students to be in a queue in their high ascending order of their height, then say this is U. So U, your height, we consider here it is the marks, but if we consider say height, if we consider that your height, say for example 170 centimeter, is such that your percentile value is coming to 70 centimeter, 70th percentile. What does it mean? It means below your height value, how many other students are there? 70% students are there. And below your, above your height, how many students are there? There are 30% students. Similarly, in case of marks also, so you got 80% marks, that is out of 50 you got 40. It is, we are telling it is 70th percentile. What does it mean? It means you got, your marks is such that it is higher than 70% students marks and it is lower than 30% student marks. Another example, if I mention that your percentile or your rank as per your score is 60th percentile, what does it mean? 60th percentile means below your marks, how many students marks are there? Below your marks another 60% students got the marks below your mark. Another similarly, above you, how many students got marks? 40% students got more than you. So that's why your position or rank in the class is 60th percentile. So in this way, percentage and percentile is completely different. Percentage, when your marks is converted out of 100, that is the percentage, but your rank, while you are expressing in percentile, it means if we consider the marks as a data for all the students' marks, if we tabulate in ascending order or descending order, then say someone got 40, someone 41, in this way someone say out of 50 got 49. In this way, if we arrange the marks in ascending or descending order, so if we put like this way, so someone got 38, someone 39, someone 39.5, 40, in this way someone got 48, 49, someone got 42, 50. If this is the scenario and I am telling, say you got 48 marks and this marks I am telling it, your rank is 90th percentile. You got 48 marks out of 50 and your rank in the class is 90th percentile. What does it mean? How many? Mean another 10% student, here are 10% student who got more than you, and here are 95% students who got less than your mark. So 90th percentile mean any specific percentile. You got 48 marks and that marks is 90th percentile. It means 90% data, mean marks data is below this 48 and 10% of the total data is above this 48, and those data actually corresponding to students, mean a 90% student got less than your marks and 10% student got more than your marks. Same thing can be, we can give the example of height. So this is the marks. Similarly, if we discuss the same thing with height, so in a classroom there are so many students, someone's height is 140 centimeter. This is height value and expressed in centimeter. So 140 centimeter, 141 centimeter, 142 centimeter, 142.5 centimeter, 143 centimeter, again 143 centimeter, then in this way 145 centimeter, 148 centimeter, 160 centimeter, 180 centimeter, 178 centimeter. So in this way we can put the height value of all the students starting from 140 centimeter and it is ending at 180 centimeter. So these are the, if we measure the height of all the students and put those height values in ascending order, then we are getting this type of data set. Out of the data set, assume this is your height, 142 centimeter. 142 centimeter is your height value, and in this height data set we are telling this is such a data, this data is 5th percentile. If we mention that in this data set 142 centimeter is 5th percentile, it means 5% data are below this 142 centimeter and 95% data are above this. So 5% data are below this 142 centimeter and 95% data above this 42 centimeter. Similarly, if we mention, say your height is another, if your if we mention your height is 148 centimeter, and if I say not one, okay, say 177 centimeter, this is one height value. This height value, if we mention, this is 95th percentile. If we mention 177 centimeter, this is 95th percentile. What does it mean? Within this data set, 177 centimeter is such a data. Above that, 5% data is there, and below that, %95 data is there. So if we discuss about this one, that in this data set, while it is arranged in ascending order, if we mention that 177 centimeter is such a data in this data set, if we call this is 95th percentile, it means above this, how many data are there? 5% of the data are there. And below this value, how many data are there? 95% data are there. That's why it is 95th percentile. Now, how to calculate percentile? There are different methods. So, one way to calculate percentile value from this frequency diagram. So, what is frequency diagram? So, within the say, this is the height of a group, particular group, height starting from 160 centimeter and it is ending at 180 centimeter. And now we have divided in small interval 160 to 162 centimeter, 162 to 164 centimeter. So, within this group 160 centimeter to 162 centimeter, within this range how many students are there? Say 10 students are there. 162 to 164 centimeter, how many students? 15 students are there. So, this is called frequency or number of individuals in that particular group. So, it is very clear. In this way, the whole range we can divide in small intervals, and within each interval how many members are there we can tabulate it. So, that is the frequency or number of individuals in that particular group. Now, what is cumulative frequency? Now, what we present here, 160 to 162 centimeter, within this range 10 people are there, but 162 to 164 centimeter, here are 15 individuals. But in case of cumulative frequency, it is coming 25. How? 10 plus 15 equal to 25. Means actually in this position, what we are writing. So, first one, while we are talking about cumulative frequency, it means it is actually below that 160, it is starting from 160 and ending at 164 centimeter. Within this range, how many people are there? Total 10 plus 50. So, actually this 25 is coming within the group 160 centimeter to 164 centimeter. Similarly, in this case, this is the 17 for the particular group range 164 centimeter to 160 centimeter. Within this range, there are 17 number of students and some number of individuals. And but cumulative frequency 42 mean up to 166 centimeter, starting from 160 to 166 centimeter. Within this range, how many students are there? That is 42. Mean we have to sum up 10 plus 15 plus 17. That is coming to 42. So, in this way, in cumulative frequency, we have to add in each group whatever is the frequency or number of individuals, that we have to sum up one after another. In this group 174 to 172 to 174 centimeter, within this range how many students are there? 29 students are there. But what's the cumulative frequency in that for that group? Cumulative frequency is 136 centimeter. How this 136 centimeter is coming? Then you have to add starting from 10 up to this 29, then it is coming to 136 centimeter. So 136 number of students actually belongs to in that group starting from 160 centimeter and ending at 174 centimeter. It is starting from 160 and ending at 174. Within this range, total number of students is 136. So in this way, cumulative frequency is calculated. Now, if we plot the cumulative, how it is plotted in the graph, cumulative frequency diagram. In case of cumulative frequency diagram, as we mentioned, we have to sum up the frequency. So 162 to 164 centimeter, within this range, how many students are there? That value you have to put here. So 160 to 162 centimeter, how many? 10. 160 to 162, we are putting 10 there. Then next one is 162 to 164 centimeter. Within this range, it is 50. But cumulative frequency, when we are talking about, then that is 25. So we have to put here 25. Next, 42. In this way, whatever the cumulative frequencies are there, because on x-axis we are putting the height and on y-axis we are putting the cumulative frequency. So whatever which are the cumulative frequency in that particular we kept against that particular group, we have to put here. So in this way, in different these small intervals, whatever intervals are given, within each interval we are putting cumulative frequency. Then we are getting this type of graph. So here how many total? 200 students are there. So 200 students data we can plot like this way. Now in this plot, what is happening? So 200 students mean total 100% students. Now for a particular, say 150 number of students. 150 number of students is coming like this, and it is intersecting at this point of the graph, and if we come there, then we are getting the value. So if 200 is the 200 students is considered as the 100% students, then 150 mean 70%, 100 mean 50%, 50 mean 25%. So 100 we are considering 100. So 100 number of students, 100 students mean 50% students. So because total students is 200, 50% students height value is below this value. That is, we can easily from this graph we can identify what is the height value on x-axis. In that way we can mention that value is coming to 171.5 centimeter. So below this 171.5 centimeter, how many students are there? 100 students are there. That 100 students actually refers to 50% of the student population. So this value 171.5, that we can call 50th percentile. So in this way we can calculate the 50th percentile value. So 171.5 centimeter, this is a value in the data set. Below that data, how many students are there? 100 students are there. 100 students mean 50% students, because total students is 200. Similarly, say if we consider this 50 number of students, 50 number of students mean 20% students, 25% students. Out of 200, 50 students mean 25% students. Those 25% students height value is actually below this point. What is this point? This point is 168.84 centimeter. So 168.84 is such a height value in the data set. Below this value, 50 number of students mean 25% students are there. 25% students are there mean this value we can mention as 25th percentile student. Below this 25th percentile height value. So 25th percentile height value is 168.84 centimeter, mean below this value 25% students mean 50 students are there, and above this how many students are there? Above this height value, remaining portion mean remaining 75% students are there. Now again we are going back to the definition of percentile. So what is percentile? So percentile, if we mention 70th percentile, 70th percentile means this is in a data set, this is a specific value, below that value 70% data are there, above that value 30% data are there. Now how we can make a generalized definition? Percentile can be defined as a particular point in the data set, below that certain percentage, in that example 70%, certain percentage of data exists, and above that remaining percentage of data exists. But the condition is that we have to arrange the data in ascending order. So while we are arranging the data, as in this case also we have showed, while we are arranging the data in ascending order, any percentile mean below that particular point, 142 centimeter, 5th percentile, below this percentile value 5% data set are there. Above this 142 centimeter, which percentage of data is there? 95% data is there. So percentage, what is percentage? What is percentile? So percentile is a specific position or specific point in the data set, below that certain percentage of the data exists, and above that remaining percentage of the data exists. So percentile is not any individual or is not any, say, height. This is the height value. So height is not the percentile, or the student is not the 70, this 5th percentile height. Mean percentile is used for the data. So his height value is 5th percentile. Neither the student is 5th percentile, neither the height is 5th percentile. That height value in the data set is 5th percentile. His height value 142 centimeter is a specific data which we can mention as 5th percentile for the data set. Now moving forward, then few other anthropometric parameters as statistical parameter, which are also important for understanding the anthropometric and percentile calculation of anthropometric and biometrical data, is mean, median, mode. So mean, median, mode, these are called central tendency of the data. So what is mean? All of we know mean is the how we can define mean? Mean is a statistical parameter, implies arithmetic average or arithmetic mean, which is obtained by summing up all the observations and dividing the total by the number of observations. So this is expressed as like this. So x is the individual observation, all the individual observations we have to sum up, then we have to divide by n. Now n is the total number of observations. For example, so if we give an example of a data set where these data are there, 2, 5, 8, 6 individual data are there, then how we can calculate the arithmetic average or mean? Then we have to sum up all the values and then we have to divide by the total number of data points in the data set. So in this data set there are total 13 data. So we have to divide it by 13. Then we are getting the mean value or average value for the data set. Now next is median. This is also another central tendency of the data or data set. What is median? Median is the mid value. This statistical parameter implies the mid value or middle observation while the data is arranged in ascending or descending order. The same data set if we consider and then if we arrange them in ascending order from lower value to higher value, then whatever is the mid value, that is called the median. So here we have arranged, we can find this side there are 1, 2, 3, 4, total 6 number of data points are there. Above this value there are total 6 number of data points. So mid value is the 5 So for this data set, 5 is the median. Next, mode. There is another parameter for central tendency, that is called mode. This statistical parameter implies the most frequently occurring value in the data set, that which in the data set any particular value which is coming for more number of times, that is called mode. With the same data set example, we can mention that in the data set we can find 5 is coming for how many times? 5 is coming 1, 2, 3, 3 times. 5 is coming 3 times. So 5 is the mode for median, also 5, and mode is, in this case, mode is also 5, because in that data set 5 is coming for 3 times. Now one important thing here, generally for all our everyday purpose we use arithmetic average or mean. Then what's the importance of mode or median? There are some situations where median may be more expressive for central tendency than mean, because the central value or mean value for a data set may be expressed more by median than mean. When it happens, see, in a data set, if few values are too small or too high, even in this example, if few data, in general it is starting from 140 and gradually increasing 180 centimeter, but at this end, at one end, either at bottom side or top side or bottom side, we will find if one or two value are very, say 140 centimeter, another value is only 120 centimeter, another is 122 centimeter. If one or two values at the two end are very smaller or very larger, then what will happen? Due to presence of those data, the average value or arithmetic means actually does not show the central tendency. In that case, median will be the better representative of central tendency. So in a data set where one or more number of values, very small or very large values are there in the data set, which actually deviating or which actually affecting the mean value, due to presence of that value at the lower end or higher end, if it is affecting the mean, in that scenario median may be the better representative. Now, next important statistical parameter is standard deviation. We are coming to this example. Say this is also student's height in centimeter. So it is starting from 140 centimeter and ending at 171 centimeter. We are assuming, so sum is this and mean value is this much, and we can calculate a standard deviation. So mean value is 155 centimeter. So its mean value's position is somewhere here in between 155 and 157. So mean value actually lies in between these two values. So all the data in that data set are arranged in ascending order. Now, if we look at the mean value 155.8 centimeter, from that mean value, this 152 centimeter, there are some distance. Few values are nearby. 150 is nearby, 154 is going away, 153, 152. In this way, it is gradually the distance is increasing. 140. Similarly, this side also from 155 to 160, 161, gradually the distance is increasing. So actually, then what standard? Mean is clear. Mean is the arithmetic average. Now, what is standard deviation? So standard deviation actually indicates how all these data points are dispersed or scattered around this mean value. If this is the mean value, from that mean value, how all other distance are away from, whether these values are nearby mean value or away from mean value. So for that purpose, how we can calculate this standard deviation? So standard deviation is calculated with some formula. What we do? First we calculate the mean value, this is the mean value. Then from the mean we make the difference. So make the difference from mean minus individual observation. So 155 minus 155, 155.8 minus 155, then again we can make this type 155.8 minus 153. In this way we can calculate the difference. So first we have to calculate the mean, second we have to calculate the difference of individual observation from the mean. Now if we look at this side, as these values are lower than 155.8 centimeter, so whenever we will minus all these individual value from 155.8 centimeter, it is giving positive value. All the differences are positive. But on the other hand, while we are subtracting 155 minus 158, then we are getting negative value. So this side, while we are making the difference between 155 centimeter and individual values, then what is this side? The differences from this individual value, those values difference from the mean value is coming in negative. So for this purpose, what we do? So make all these negative value to convert it positive. At the same time, this side is already positive. So what we do? We add then we go for square the difference of observation. So first we calculate the mean, then we calculate the difference between mean value and individual observations. Whatever difference we are getting, then we have to make the square of that value. Then all this side value as well as this side value will come positive. Then we have to sum up all the differences. We have to sum up after squaring. So add the squared values to get the sum of squares of deviation. Then when we are getting that squared value, then divide the sum by the number of observation minus 1 to get the mean square deviation. Now if there are total, as this is a sample, in this sample how many values are there? Say for example here are 20 values are there, mean 20 data are there. Out of the 20 data, we are then here degree of freedom is called, degree of freedom means, but now one important part is degree of freedom. Degree of freedom means in a data set how value can be changed or the data point can be changed other than that particular value. If the total number of data in a data set is 20, so for a particular position or particular value, it can be changed to another 19 values. So that's why for that particular value, total degree of freedom is 19. So in that way, for this sample, if we assume that there are total n number of data point, then degree of freedom for that data set is n minus 1. We have to divide that squared sum with the n minus 1. That is the degree of freedom. Then, as we have already seen, mean, if m here, m is the, now we are coming to the statistical expression. In the statistical expression, what we can see, m is the mean value. Mean value, this is the mean value, minus x is the individual observation. Either this side or that side, all these individual observation. This may come positive or negative. For that purpose, we are putting square to make all the differences in positive form. While it is coming in positive, then we are dividing it by n minus 1. Total number of observation minus 1 as the degree of freedom. But if this is a sample data, but if it is a population data or very big data, the number of sample size is very high or very big sample size or a population data, in that case even instead of n minus 1 we can use n. So anyway, so here we are using, as this is a small sample, we are using n minus 1. Then as initially for making all the difference which were in negative or either positive. In positive mode, we squared it. Now, as we put the square, now again we are putting the square root out for the whole expression. Then it is giving actually one expression that is expressing that how all other values in the data set are dispersed for mean value. So mean value minus individual value, then square that one, after squaring divide it, so that after squaring whatever and sum up, then whatever value is coming, that is happening for n number of data. Then to get the average value, we are dividing that expression m minus x square divided by n minus 1. Then we are getting the average value. After getting that average value, as we put that square, now again we are putting the square root. So ultimately, standard deviation is a statistical expression which is expressing that how, while the data are arranged in ascending order, or it may be also in descending order, while the data is arranged in ascending or descending order, then from the mean value, how all other values are dispersed around the mean value. Now this is very important. If the mean values of two different data sets are equal, data with lower standard deviation value indicates that data in that data set are less scattered or less dispersed around the mean in comparison to another data set. We are giving that example. So these two data sets are there. So this is one data set where this is the mean value. Now as we mentioned, what is standard deviation? We mentioned standard deviation expresses how all other values in the data set are dispersed around the mean value. From this mean value, few data are nearby, few data are away from the mean. So it is like this, some value are nearby, some value are away. So ultimately, say for this data set, mean value is coming to say 40 and standard deviation is coming to 5. Another data set where mean is the same, mean value is same, in this case also mean value is 40, but standard deviation value mean how all other values are dispersed around the mean value. If we calculate that one, then standard deviation is coming to 2. In both the cases, mean value is same, 40, 40. But in this case, standard deviation is 2. In this case, standard deviation is 5. So what does it mean? In this case, all values are more dispersed around the mean. In this case, values are nearby mean value. That's why standard deviation is less. So standard deviation actually expresses how all other data in the data set are dispersed around the mean value. If those are nearby mean value, then standard deviation value is less. If those data points are dispersed around the mean value or away from the mean value, then it is coming, standard deviation value is more. Now, next is normal distribution and normal curve. So, normal distribution is one type of standard distribution which occurs in our nature. So, generally, as we are discussing about frequency diagram, similarly, if we look at this table, then it will be easier to understand what is normal distribution. So but first we need to know why we find this normal distribution. Generally, while we talk about normal distribution, we mentioned we will get this type of bell-shaped curve. But when the data collection is random, sample size is big, random data collection is there, and the overall we are getting this type of bell-shaped curve, then we can mention that data is following normal distribution pattern. So how does it happen? So if we consider the height value for a particular group of students or a particular population, so for example 142.5, below this how many students are there? 3. 145.5 to 147.5, how many? Below 148 centimeter, 145 centimeter, 8. Then below 145 to next is, this is the frequency for each group, 145 to 147.5, how many students are there? 50. So in this way, with a small interval in each group, number of students is given here. Then what we are getting? At the below range 3, 8, gradually it is increasing, and at the end also middle it is value is more, at the end it is again reducing. Even in any population, even for the example of a big classroom, if we find how many students are very tall, number is very less, 1 or 2. Similarly, how many students in a class are very smaller in size, answer is very limited, 1 or 2. But more number of students with average body dimension are found. So for that purpose, if we put this type, say for on x-axis, if we look at this graph on x-axis, this is the height value, and this is a small interval, 142.5 centimeter, 142, 145 centimeter, then 147.5 centimeter. So within this each interval, how many students are there? At the smaller lower range, 142, below 142.5 centimeter, only 3 students are there. 142.5 to 145 centimeter, how many students are there? 8 students are there. 144.145 to 147 centimeter, there 15 students are there. So in that way, we can see while we are going towards the mid range, the number of students in that particular group is gradually increasing. Again from the mid range, while we are moving towards the higher range, higher values of the height, then number of students in that particular group it is reducing. So as I mentioned, so this is the height value on x-axis, these are the height value, and on y-axis we have kept the number of students in that particular group, that is the frequency. So number of students in the mid range, 157.5 or 160 centimeter, in that range the number of students are more. But while we are going towards lower side or we are going towards higher side of the height value, the number of students in that particular group it is reducing. Ultimately we are getting this type of bell-shaped curve. So this bell-shaped curve is called normal distribution or normal curve. While the data set follow normal distribution, then we get this type of normal curve. So few characteristics are mentioned here. So that should be bell-shaped. It is generally this type of curve is observed. Then symmetrical from the midline, both sides are similar. Mean, median and mode, if any data set follow normal distribution pattern, then this is very important observation, that mean, median, mode, everything coincide, and the curve changes from central convexity towards concavity at the both end, lower end as well as upper end. Now non-normal distribution and range, and what's the relation with percentile. So in this graph, on x-axis we are keeping height in centimeter, and on y-axis this is the frequency. Now if we draw the same thing here, so we are putting height in centimeter on x-axis, and on y-axis we are putting the frequency. Frequency, number of students in that particular group. Now, for a particular class, say starting from 140 to 142 centimeter, within this group, how many students are there? Only 1 or 2 students are there. So this side is the number of students. So total 50 students are there. This is 25. This is 20. This is 10. And this is say 30, 40, 50. So 140 to 142 centimeter, how many students are there? Only 2-3 students are there. In the next group, how many students are there? Number of students is more. 140 to 144 centimeter. Similarly, in this way, while we are coming to mid range, say 160 centimeter, then number of to 162 centimeter, within that range, number of students are more. How many students are there? Say 40 students are there in that range. Similarly, while we are going to upper side, say 180 centimeter to 182 centimeter, within that range again number of students are less. In between, say 172 to 174 centimeter, within that range number of students are relatively more. Similarly here number will be more. So ultimately we are getting this type of bell shaped curve. Because students with average body dimension or average height value or any other body dimension, their number is more. Students with lower body dimension value, their number is less. Similarly, students with higher body dimensional value, their number is also less. So we will get this type of bell shaped curve. Now for this data set or for these students, we are assuming mean value say 160 centimeter and standard deviation value is say 3 centimeter. So for a particular population, if mean value is 160 centimeter, so this is the mean value 160 centimeter and standard deviation value is 3. Now from the statistical analysis, while any data set follow normal distribution, then it is observed that, as it is mentioned here, mean plus one standard deviation value covers 68% of the population. Mean from the mean value, if this is the mean value point, from that 160 centimeter mean plus 1 standard deviation value covers 68% of the population. From the mean value, if we go 1 standard deviation up or 1 standard deviation down, so this is the mean value. From mean value, if we go 1 standard deviation up or 1 standard deviation down, then it is actually covering, this is the mean value point, mean value. From that we are going plus 1 SD or minus 1 SD. It is actually covering what percentage of the population? It is actually covering 68% of the population. This is observed for any data set which is following normal distribution. Now, so mean plus or minus 1 SD, it will cover 68% of the population. Now, from the mean value, if we go 2 SD, from here if we go 2 SD, this side, up or 2 SD down, then 2 SD means here it is written 1.96 SD. So mean plus it is almost 2. So mean plus 1.96 SD covers 95% of the population. So if we know the mean value 160 centimeter, from that first case mean value plus minus 1 SD, 1 into standard deviation 3. So 160 centimeter plus or minus 1 into standard deviation value 3, this actually covers 68% of the population. From the mean value 160 centimeter, if we go 1 time standard deviation value is 3, 1 into SD value 3, actually that within that range mean 160 centimeter plus 3 mean 163 centimeter to 160 minus 3, 157 centimeter. Within this range 68% of the population exists. Similarly, from the mean value 160 centimeter, if we go 2 into SD value is 3, it is actually giving, it is actually covering 95% of the population. 2 mean actual value is 1.96. Anyway, I am putting 1.96. So mean plus or minus 1.96 SD value is 3 here. In this case, example we have mentioned SD value is 3. So mean value plus or minus 1.96 SD, within that range how 95% of the population is covered. So 160 minus 6, 154 centimeter to 160 plus 6, 166 centimeter. We can write in opposite way. So 157 to 163 centimeter. Within this range we are covering 68%. 154 to 166 centimeter, within this range we can cover 95% of the population. So from mean value, if we go 2 standard deviation from this mean value, if we go 2 into standard deviation value, then actually we can cover 90%. This actually covers 95% of the population. So this is the range. The same thing is also shown here. So from that mean value, this is the midpoint mean value. From mean value, if we go 1 SD upward or 1 SD downward, so here we give that example that if 160 centimeter is the mean value, from that if we add 3 centimeter positive or if we subtract 3 centimeter, within that range 60 within this range, in this dotted portion, it covers 68%. Similarly, from the mean value, that midline, if we go almost 2 SD or 1.96 SD, 1.96 times of standard deviation, then from this point to this point, it actually covers 95% of the population. And mean plus minus 2 into standard deviation, it actually covers 99% of the population. So in this way, we understand that if we can, for a data set or whether that is anthropometric data or biometrical data, from that data, if we can calculate the mean value and we have the standard deviation value with us, then we understand from that mean either we will go within some range, positive direction or negative direction, 1 SD up or 1 SD down, it will cover 68%, mean value 1.96 SD, positive side, negative side, within this range it covers 95% of the population, mean plus 2.58 SD, then it actually covers 99% of the population. Now, one important thing, generally for design purpose, we mention that we want to use 5th percentile, 50th percentile and 95th percentile anthropometric data. Why? From this graph, as we are discussing, if we extend that, then we understand mean plus minus 1 standard deviation actually covers 68% population. But what do we get? Actually, we are accommodating mean plus 1 SD. If we calculate, that actually gives us the 84th percentile. Mean minus 1 into standard deviation value, whatever value we will get, that is actually 16th percentile data. So, from 60th percentile to 84th percentile, actually you are covering 68% of the population. Similarly, from mean value, if we go 1.64 SD, in positive direction or negative direction, it is actually covering 90% of the population. Mean we are accommodating 5th percentile to 95th percentile. So in that way we can mention, say we are mentioning this is covering 95%, means remaining portion, this side remaining portion is 2.5%, this side is also remaining portion is 2.5%. Similarly, if we want to cover mean plus 1.64 SD, it covers 90% of the population. If it covers 95% population, it means 5% population is below that range and 5% population is above that range. Only it is covering mid 90%. Mean, this is the mean value, say this point is 160 centimeter. From that, if we go 1.64 time SD value, then wherever we are reaching, that point is actually 95th percentile. So we can easily calculate. How to calculate? In other way, how to calculate 95th percentile data? If the data set follow normal distribution, then with the mean value, if we add 1.64 time SD, then we are getting 95th percentile value. Mean value minus 1.64 SD, then we are getting 5th percentile value. So within this range, mean plus minus 1.64 SD, actually we are covering starting from 5th percentile and ending at 95th percentile. The in between these two percentile, 90% of the population is covered. Similarly, from mean value, if with the mean value, if we add 1 time SD, actually we are calculating 84th percentile data. Similarly, with the mean value, if we subtract 1 SD, then actually we are calculating 16th percentile data. So from 16th percentile to 84th percentile, the range, which range we are covering? We are covering 68% of the population. So in that way, in mean plus 1.96 SD, we covers 95% of the population. Mean plus 1.96 SD actually give us the value of 97.5 percentile data. Mean minus 1.96 SD give us the value of 2.5 percentile. So starting from 2.5 percentile to 97.5 percentile, we are accommodating 90% of the population. Next one, from with the mean value, if we add or subtract 2.58 SD, then actually we can cover 99% of the population or data set. It means it actually starting point is 0.5 percentile and end point is 99.5 percentile. Now the question, why do we use 50th and 90th percentile? So generally 50th percentile is for average dimension. We will discuss in details. So starting from 5th and ending at 95th. If we understand this graph, then from that we can visualize this, that mean in plus minus 1 SD covers 68%. If we increase it to mean plus minus 1.64 SD, we are covering actually 90. Starting from 68, now we are covering 90%. So if we increase the SD value from 1 to 1.64, actually we are covering another 22% of the population. If we consider only mean 1 SD, we can cover 68% of the population, but if we consider mean plus minus 1.64 SD, then we are covering 90% of the population. So what's the extra percentage we are covering by using this 0.64 SD mode? We are actually covering 22% extra. Similarly, if we go for 1.96 SD, then we can cover 95%. So what's the increment from 90%? Now it is 95%. Earlier it was 90%, now it is 95%. So only 5% extra we can accommodate. But so this indicates that while we are increasing the SD value from 1 to 1.64, it is accommodating a good amount. It is increasing accommodation of good amount of population, that is 22% extra. But from 1.64 SD, if we increase almost 1.64 to almost 1.92, then only we are increasing the accommodation of 5% extra people. So we should not go for this. We should go for only this one. It is better because as much as the standard deviation value, what the standard deviation value means? Actually, we can explain it in some other way. Say for example, if we are designing this chair, in this chair, so this is the mean height of the chair. For mean height of the chair, seat pan height say 40 centimeter. This 40 centimeter seat pan height, or we can draw it. So this is a chair. So this height is 40 centimeter. So you are assuming that leg height for that chair is mean value is 40 centimeter. So how we have decided that what should be the leg height of that chair? So for that purpose, we have collected the anthropometric data. From that anthropometric data set, we have calculated the mean value or 50th percentile value. So mean value or 50th percentile value is coming to 40 centimeter. Now for that particular 40, so this is the leg height value for the chair. We need to design this one. What should be the value? For this purpose, what's the corresponding anthropometric variable, what's the human body dimension for that, that is we call popliteal height. In general term we can mention is leg height of human. So one human being is sitting there, we need to consider his or her leg height. So this is the leg. So if we imagine this is the human being, so while that human being is sitting, this is the dimension we need to consider. Exact anthropometric variable we call it popliteal height, that height from below the thigh to up to the bottom surface of the sole. So that is the popliteal height. So popliteal height, we have measured the popliteal height of a big sample, and we are calculating the mean value is 40 centimeter. So accordingly, if we design this chair as per the 40 centimeter popliteal height, then 50th percentile person can sit comfortably, because it is as per his body dimension. Now from that height, if we now from side view, so this is the chair. So initially it is at the mean value, that is 40 centimeter. Now if we increase this height, the standard deviation value for that anthropometric variable is 2. That anthropometric variable means popliteal height, or we can mention leg height. So popliteal height, the standard deviation value is 2. So with mean plus, from that if we go 1 SD means 2 centimeter. 40 centimeter, if we go 40 centimeter to 42 centimeter, or we can come to 38 centimeter. From that mean value, if we go 2 centimeter up or 2 centimeter down, mean 1 SD, one time SD, then we can accommodate 68% of the people. But if we go mean plus 1.96 SD up and down, 1.96 SD means almost 2 SD, mean plus 1. Anyway, so we are considering 1.64 SD. Now from mean, this is the mean value. From mean value, if we go 1.64 SD, then we can cover. So this is 1.64 SD. Then we can cover from that. This is the mean value. From that mean value, we are increasing 1.64 SD up, 1.64 SD down. Then within this range, from this point to this point, which percentage we are covering? We are covering 90% of the population. So initially we are using from mean value 1 SD up, 1 SD down, we are covering 68%. Now from the mean value we are going 1.64 SD up, 1.64 SD down. Within that range we are covering 90%. So actually we are increasing the accommodation of 22% more people. So for that purpose, we should always try to accommodate 90%. We are accommodating 90% of the population, means it is starting from 5th percentile to and ending at 95th percentile. 5th to 95th percentile people with this popliteal height or lower leg height, starting from 5th percentile to 95th percentile, in between this 90% of the population, they will be able to use this seat if the height adjustability of the seat we adjust like 1.64 SD up and down. So from mean value, so this is beneficial for us. From mean, if we go 1 SD, then only we can cover 68%. But from mean, if we increase or decrease 1.64 SD, then we can cover 90%. So extra 22% can be covered or can be accommodated. But after that, again, if we increase the SD value, only we can increase the accommodation of 5%. From 1.64 SD, if we increase to 2.58 SD, then we are increasing only 9%. For that purpose, we do not go, because as much as standard deviation value, means as much as adjustable feature we will add, then the facility will become fragile. It will be broken easily. For that purpose, we should not go for increasing the SD value as much as possible. If we increase, you can increase it. Mean plus 2 SD, 3 SD we can increase. But with that increment, the number of people or percentage of the population being accommodated, that is very less. For that purpose, we will concentrate on this area. This area means mean plus 1.64 SD. If we use, then we can cover 90% of the population. Mean we are considering 5th percentile to 95th percentile of the anthropometric data. If we use 5th percentile to 95th percentile anthropometric data, then we are covering actually 90% population. But for that purpose, how much SD we are using? We are using only 1.64 times SD. So this is very good compromise, because we can also increase the standard deviation, but as much as standard deviation value will increase, we will increase a more adjustable feature, that system or that facility will be fragile and it will be easy to break down. So this is the reason for which, to accommodate more number of people, we go for up to accommodating 90% population in 5th percentile to 95th percentile. But we should not go for accommodating 0.5th percentile to 95th percentile, 99.5th percentile, because in that case we have to use 2.58 times SD. Why do we use more SD value? Or mean we are making the adjustable feature more, it is becoming much more fragile. And only very limited number of people are being accommodated with the increase of standard deviation value. So for this reason, we use 5th and 95th percentile data to accommodate 90% population, where only we use 1.64 times SD. Now already we discussed this one, that for if we know the mean value and standard deviation value for a data set which is following normal distribution, then we can calculate various percentile value, 1st percentile, 2nd percentile, or 5th percentile, or 50th percentile as per our requirement. So here these are the Z is the constant value, here is also the constant value. If we want to calculate, say for example 5th percentile or 95th percentile value, then how to calculate? This is the constant value. For a specific percentile, if we want to calculate, then we have to go for mean value plus or minus standard deviation value. So if we want to consider 5th percentile, calculate 5th percentile value, then what we will do? From mean, obviously mean 50th percentile. Mean value indicates 50th percentile value in case of normal distribution. So if this is the 50th percentile value, obviously 5th percentile value will be less than that. For that purpose, we have to go for minus. This value is a minus. So mean minus 1.64 times. So this minus 1.64 times. If we want to calculate 5th percentile, then with the standard deviation, we have to multiply minus 1.64 SD. Mean minus 1.64 times SD. Then we are getting 5th percentile value. Similarly, if we want to calculate 95th percentile value, then how we have to proceed? Mean value or 50th percentile value. With that 50th percentile value, we have to add 1.64 times SD. Then we will be able to calculate 95th percentile value. Similarly, say if we want to calculate 25th percentile value. So in that case, what we have to do? To calculate 25th percentile data, mean minus 0.67 SD. Then we will be able to calculate 25th percentile value. Similarly, if we want to calculate 75th percentile value, for that purpose we have to calculate mean plus 0.67 into standard deviation. Then we will get the 75th percentile value. So from this type of standard values of Z, we can calculate various Z value or constant value. With that constant, we have to multiply or calculate a standard deviation value to calculate various percentile data. Now body plane. Now after so far what we discussed. So far we discussed, if we recall, so few basic statistical parameter like percentage, then percentile, gradually move to various types of central tendency, mean, median, mode. Mean is the 50th percentile value in case of normal distribution, because in case of normal distribution, mean, median and mode value coincide. Then we again discussed about the standard deviation value, how it is calculated and what's the meaning of standard deviation. Then normal distribution. Then we also discussed how, if we know the mean value and standard deviation value for a particular data set which is following normal distribution, then we can calculate various percentile value. At the same time, we understand that how a specific range, either 68% or 90% or 95% population, within which range it is actually being covered. So that is also shown here, that if we know the mean value and standard deviation value, then we can calculate and we can accommodate certain percentage of the population. Then this is the same calculation of percentile. Now after understanding these basic statistics, now we are moving towards our main topic, anthropometric and biomechanical data. So for that purpose, initially we should know little bit about the human anatomy, body planes and various landmarks. So basic knowledge of human body, these body planes are important. So here you can see, we can describe human body in various planes. So if you look at this plane, this one, there are different directions where it is mentioned, x, y, z direction. So if forward direction is x and upward direction is z, then this plane is called xz. Xz plane, forward direction in front, if we mention forward direction is x, upward direction is z, then this plane is called xz. This plane is called sagittal plane. So what this sagittal plane is doing? Sagittal plane is actually the plane which is dividing our body in left and right half. So this is the plane in front of our body. If we assume that forward direction is x-axis, upward direction is z-axis, then this xz plane, it is dividing our body into two halves. This is called sagittal plane. Another is, if we look at this plane, yz plane, if we mention that y-axis is sidewise and z-axis is upward. Y-axis sidewise, z-axis upward. So this plane is actually yz plane. Yz plane is called coronal plane. This coronal plane dividing our body in frontal, forward and backward. Frontal and backward, or ventral and dorsal half. So this plane is called coronal plane. So one plane is sagittal plane, that is dividing our body into two halves, left and right. Similarly, this plane, yz plane, dividing our body frontal and backward portion, back portion in ventral or dorsal half, that is called coronal plane. Similarly, there is another plane, that is, if x-axis is forward and y-axis is sidewise, x forward, y sidewise, then this plane is called transverse plane. So this is dividing our body in two halves, up and down. So these planes are very important because while during our anthropometric or biomechanical discussion, biomechanical study, while we are discussing human body parts or its movement, then we have to explain that, say for example we are describing hand movement, then we have to mention in which direction x, y, z, that coordinate system, at the same time in which body plane that particular body parts is moving. So defining the posture, defining the human body motion, these planes are very helpful. Now similarly, if we look at, we should also know, students, for the students it is important to understand basic anatomy of human body, the skeleton structure, numbers of bones, how those bones are arranged in human body. All these informations are very much important for digital human model, because in digital human model what we do, as we have mentioned earlier also, that is actually human body representation. Digital human model means CAD representation of human body. So if we know basic anatomy and the structure of human body, then it will be easy for us to understand digital human model creation and its use for different types of ergonomic evaluation. So from any anatomy book we can go through and we can understand that how those bones are attached with one another, different types of joints are there, and the same time landmarks. There is another word called landmarks. So there are some specific points on the body which we can clearly identify from outside, so that if we want to measure human body dimension, say if I want to measure hand dimension, then from this point to that point. So there are some specific points on the body should be identified, which can be easily identified by some other person also. And from those, say if we mention the lower arm length, from where to start and where to end, how will we define? For that purpose, specific bony marks on the specific position of bony protrusion, those we have to identify. Protrusion or any other foldings we have to identify. From that we will measure the body dimension. So different landmarks, say for example one is acromial. So we have to know this is the acromial position. Then those, if we know those points, then it will be easier for us to measure human body dimension. Now if we look at our overall skeleton structure, so this is the vertebral column where our skull is attached. This vertebral column. So in vertebral column or our backbone is made up of many bones. If we look at the cervical portion or neck portion, how many bones are there? There are total 7 bones, 7 movable bones. So with the 7 movable bones, we can move our neck. Then next portion is the thoracic portion, the chest portion. There are total 12 movable bones are there. So next thoracic portion, in thoracic portion or chest portion, there are total 12 bones. Next portion is called lumbar portion. So if we, so first neck portion, then thoracic portion, then lower back portion. This portion is called actually lumbar area. This lumbar area, here it is represented like this. So in lumbar area, how many bones are there? 5 movable bones are there. Lumbar area is very important for our discussion, because our forward bending or sidewise bending or rotating, even bending backward, all these actually happening with the help of these lumbar bones. These are very flexible. So while we are talking about sitting ergonomics or workstation ergonomics, then lumbar motion is very important, because this flexible portion actually allows us, although all other movable bones are also movable, thoracic or cervical, but our forward bending or leaning, or we are leaning backward, so this actually happens due to these thoracic and lumbar bones. And this in lumbar area, during heavy load carriage or load lifting or bending, there is compression. We will discuss further. Next is the sacrum. Next portion is the sacral portion. This is the sacral portion. So what in sacral portion, there are total 5 immovable bones. So if we see the backside view, then we can see these are the sacral portion. So actually there are 5 vertebrae. Those 5 vertebrae fused together, and those are immovable. Similarly, in coccygeal portion, what we call tail portion, in that coccygeal portion there are 4 immovable bones. Those are also fused. So in this way, total there are 7 and 12, 19 and 10, 5, 5 and 4. Total 33 bones are there. As these two portions, immovable and those bones are fused, so actually this is coming to 24 movable bones, and these 5 fused to making only one structure, and these 4 immovable bones are fused and they are also making one structure. So there are total, these are the 7, 12, 5, 5 and 4 number of bones. Now in between these, if you look at these vertebrae, in between two vertebrae, in two bony structure, there is some soft tissue material that is called intervertebral disc. 24 movable bony vertebrae are separated by 23 deformable hydraulic pads of fibrocartilage known as intervertebral disc. So in between two vertebrae, this portion, these are actually intervertebral disc. So during our bending, that intervertebral disc actually get compressed. Okay. Next, as we are discussing about anatomical structure, so this is from another source. So various body parts. See, if we talk about hand, so at least we have basic knowledge that there are how many bones are there. So upper portion there is humerus bone, and lower arm there are 2 bones, radio and ulna. So this type of, and what's the joint type, how that particular body joint moves. So this basic knowledge is important, otherwise it will not be possible for us to use digital human modeling software, creating human model and going for various types of ergonomic evaluation. And while in this course, while we will discuss about the creating digital human model, then this one, skeletal linkage system, that how human body can be represented with link segment. Various body segments, those are joined with this link structure. So this is linkage system. The same hand, upper arm, lower arm or palm, how we can represent with link segment. That is actually showing the skeletal linkage system. This will be very much helpful. If we understand this one clearly, then this will be helpful for our making digital human model. Now continuation to our earlier slide, where we are discussing about intervertebral disc. In between two vertebrae there is intervertebral disc. So what happens in that intervertebral disc? There are this type of, this is say one vertebra and another vertebra. In between two vertebrae there are intervertebral disc. So while we are bending forward, then what is happening? This side, one side it is getting compressed, another side it is expanding. So what happens? While there is compressive force, intervertebral disc consists of 2 parts. That is, the central part is called nucleus pulposus, and the surrounding parts called annulus fibrosus. This is regarding the intervertebral disc. Now we are discussing about the force. Due to this movement of the vertebrae while we are bending forward and backward, say if we are moving forward, then what is happening? Then this corner, while you are moving forward, bending forward, then here it is getting compressed. So what type of compression is there? There is compressive force is there. while there is compressive force, at the same time this side there is shearing force. Similarly, here while we are bending backward, then here is the compressive force. So due to the various types of bending, twisting, rotating body action, in the intervertebral disc there is change in the pressure. Sometimes there is compressive force, sometimes there is increasing shearing force. Kapanji 1974, he mentioned the disc resists the compressive load and facets resist the intervertebral shearing force. So these discs actually help us in resisting compressive force while there is compression. At the same time, this type of facet joint of the vertebrae, it helps in resisting the shearing force. Now coming to our main topic, that is anthropometry and use of anthropometric data. So first we know what is anthropometry. Anthropometry. Anthropo means related to human and metry means measurement. So anthropometry actually indicates the measurement of human body. So it is defined as the measurement of human body dimension in order to optimize the interface between man, machine and other manufactured product. So this measurement of human body is of two types. One is static measurement, another is dynamic measurement. So this is also mentioned as static anthropometry and dynamic anthropometry. So what is static anthropometry? Static anthropometry, while human body is in static posture, mean either seated or in standing posture, mean there is no movement. While human body is in static posture, that time whatever body dimension we are measuring following standard measurement procedure with standard instrument, that is called static anthropometric measurement. Example of static anthropometric measurement, say for example hand length. So what's the length of the lower arm or upper arm, or what's the height of the head. So all these measurement we can take while human body is in static posture. Sitting height, while someone is seated on the chair, then we can measure the height from the ground up to the head. So this is the sitting height, from the ground to up to the head height. So that is sitting height. Similarly, while someone is standing, then in standing posture we can measure from the ground. This is the acromial point. So acromial height. So in that way, in different static posture we can measure human body dimension that may not be always linear, only length or breadth. That may be even circumferential dimension, say wrist circumference or hand grip diameter. So different types of linear or circumferential measurement we can take. So static or structural anthropometric data are body dimension measured with the body held in standardized static posture. Static dimension refer to the actual sizes of the body components and include simple length or linear and circumferential dimensions, contours, etc. These includes height, width, breadth, depth, and usually imply no direction. So the direction is not important here. For example, foot length. Now how these anthropometric measurements are taken? In earlier days, physical measurement with anthropometric kit, anthropometric rod, different types of calipers, people used to take physical measurement. There is also other technique like photographic technique. In photographic technique, photo is taken from front view or side view, and after that with scale we can, or with chart paper we can calculate the body dimension. But nowadays there is 3D body scanning technology. With 3D body scanner, what we can do, we can scan the whole human body, and from the scan data we can go for measure n number of body dimension. including linear dimension or any other non-linear dimension, we can measure. Even we can measure at every cross section what's the area of the human body. So with the advancement of technology with 3D body scanning, now it is much more easier and to get more accurate data of human body shape and sizes. Now dynamic measures. Dynamic or functional measures are taken with the body while it is in motion. So in this case body was in static posture, in this case body is in dynamic posture. So while body is in movement, then whatever body dimensions are measured, that is called dynamic measurement, and usually more complex and difficult to measure. Dynamic dimensions refer to ability of the body to perform certain tasks within certain distances, spaces or enclosures, and include the description of measurement of human mobility, agility, flexibility. So one example, if we want to measure the range of motion of this hand. So this hand in this particular, say for example this is called flexion. So flexion, or this is in opposite direction, that is extension. So we can measure the complete range of motion. So this is not in static posture. So you have to measure the complete range of motion of this hand. It starts from this point. So this is the, if you consider initial position this one, then this is the extension, and then it is going up to this much flexion. So in this one, flexion, extension, adduction, abduction, different types of measurement we can take. So this is actually measured in dynamic postural condition. Similarly, we can measure the reach envelope. That while someone is seated, in the seated condition, what is his total reach area? Mean which area, which volume around him that particular human can access. So this reach envelope, reach zone, comfort zone, all these are described under dynamic anthropometric measurement. So basic difference is that in static it is while body is in static posture, then the human body dimension measurement, that is static measurement, and dynamic mean while even someone is leaning forward, one step forward, leaning, bending. So during that time, the total area covered by him, the total distance covered by him, we can measure under dynamic anthropometric measurement. So here it is mentioned like reach zones, comfort zone, workplace envelope, etc. measured under this dynamic. Now if we look at this graph, this is adapted from Roybach et al. 1975. So here there are total 3 graphs, 1, 2, 3, and the line characteristics of lines are also defined. So what is there? This is the various human anthropometric variables. Stature means standing height, sitting height, buttock knee length, in this way eye height. So various different variables, anthropometric variables are listed on x-axis. On y-axis, what is there? This is percentile value of USAF, US Air Force flying personnel, and their data collected in 1950. So here actually 3 persons data are there. So for one individual, if you see, this is the graph. For the third individual, this is the graph. So what does it indicate? So indicate that if we consider the first person, his stature is 70th percentile. For first person, or the stature is 70th percentile. But if we consider this one, his sitting height is actually 50th percentile. On the other hand, for the same person, this is knee height, sitting knee height, it is coming to say for 15th percentile. So for a single individual, for this particular individual, his different body parts are of different percentile. So how does it happen? So if we measure for a population, if we measure the height value of a population, and if we find, say my height value is 95th percentile, it does not mean that if we measure the hand dimension of all the people and calculate what's the percentile value of my hand length, it may not be 95th percentile. My head height value or stature is 95th percentile. It does not mean that my hand length or leg length will also be 95th percentile. It may be a different percentile. So this is a typical example is provided by Roebuck et al. That for a single individual for different body parts, it is the percentile value is actually different. If you consider the third person, in his case, while his stature value is near about 20th percentile, but his hip breadth sitting, that is coming to 50th percentile. So although his stature is near about 20th percentile or 15th percentile, but his this point hip breadth sitting, that is coming to 50th percentile. So it clearly shows that for a single individual, all the body dimension may not be of a particular percentile. If someone's height or hand length is of a particular percentile, say 90th percentile, it never means other body parts will be of 90th percentile or its nearby. It may be something different also. In reality, 5th percentile, but in reality, it is almost impossible to find out a single individual whose all body dimension is of a particular percentile value. This is very important statement, that in reality, if we find for a particular individual, say if we take the example of me only, then as I already mentioned, my stature is 95th percentile. It does not mean that my hand length is also 90th percentile or my leg length is also 90th percentile. It maybe my hand length is 80th percentile. My lower leg or my popliteal height, it is say 60th percentile. It may happen. So in reality, we cannot find any single individual whose all body dimension is of a particular percentile value. But while we are creating digital human model for virtual ergonomic evaluation, then we create this type of human model, 5th percentile human model or 95th percentile human model. What does it mean? In that case, we consider such a situation that all the body dimension of a particular percentile value. 5th percentile human model means all the body dimension of that particular human model, digital human model is of 5th percentile value. But in reality, it is not possible. But that type of optimal condition is considered so that all the 5th percentile anthropometric data can be represented by creating that 5th percentile digital human model, and that digital human model we can use for various types of design dimension evaluation. Now this is just one sample data, that how the anthropometric data are presented. These are various measurements in body parts. This is standing measurement, sitting standing, combined measurement. So stature, acromial height, elbow height, so defined anthropometric variables are given here. And this side mean value in bracket, this is standard deviation value. This is taken from anthropometric data of male agricultural workers of Assam, India. So agricultural workers of Assam state from India, this value is taken and adopted from Percentile 2016. So from the data set, we can see that if we consider stature or standing height is 1628 millimeter, and now first this is as the data is following normal distribution, so we can calculate easily first percentile, 5th percentile, 90th percentile and 99th percentile, and those data we can use as per our requirement. So this anthropometric data collection and its percentile calculation is very important, because while we are designing any facility or any product, then we need to use this percentile anthropometric data to ensure human body dimensional compatibility with the product's physical dimension. If, for example, if we see this particular research work by Patel et al., differences in anthropometric data, while Patel et al. Describing the comparison of anthropometric data of Assamese agricultural worker with various region of anthropometric data from various region of India as well as from other countries, then he mentioned, then Patel et al. Mentioned that differences in anthropometric data within and between countries indicate that simple adoption of agricultural tools and equipment from specific region might lead to occupational hazard in target population. Because there is anthropometric variation, we cannot blindly adopt one product or equipment from one country to another, because human body dimension for that particular country is different from the country or from that product or that equipment or instrument is being imported. Say for example, for Indian population, if we bring some product which is actually made for USA population, considering the human body dimension of the USA population, if the product is directly brought to India, then that product may not be compatible with Indian body dimension, because that product actually has been made considering the anthropometric database of American population. That may not match with the anthropometric requirement of Indian population. Now, if we discuss about the use of percentile anthropometric data, then first we want to discuss about this example. So if we take this example of a bench, either it may be a primary school or the primary school children, this type of bench where 4 or 5 students are sitting together, or this type of bench kept in the park, that is actually multiple user. Many people can sit there. So we cannot specify for a particular individual. So if we take the example of this bench for a classroom, so we want to design a bench for a classroom. We have to decide the leg height for the bench. So design dimension is the leg height. For deciding that leg height, what should be the leg height? What is the corresponding anthropometric variable? For that purpose, anthropometric data corresponding human body dimension is lower leg height or popliteal height. Now, if it is asked, as per which percentile data of popliteal height or lower leg height, this bench should be designed so that all the students in that classroom can use comfortably. So for that purpose, we have collected anthropometric data of the students that variable is popliteal height. So we have measured the popliteal height of the students. From that we have calculated 50th percentile data, 5th percentile, 50th percentile and okay, anyway. It will be easier to show here. So for example, from that, for that classroom, we have calculated the popliteal height, and the popliteal height we have measured and calculated 5th percentile, then 50th percentile and 90th percentile. So we know the popliteal height of the students, and we have calculated 5th, 50th and 90th percentile popliteal height. Now you want to design a bench. Now the question is, which percentile data will you use for this purpose? We want to design the leg height of the bench. So if we ask which percentile of popliteal data should be used for deciding the height of this bench, if we answer it is 5th percentile, then what is happening? 1/5 percentile student, he is sitting comfortably, his leg is exactly matching with the height of the bench. So the 5th percentile student is sitting comfortably because this height, his popliteal height, is matching with the bench height. It is designed as per his popliteal height. So 5th percentile student is comfortable. But what about 50th percentile? While the average students with average body dimension is coming, he actually facing the problem of raised knee. Then if 90th percentile students come, then his popliteal height is what? He is also facing the problem of raised knee. So only if we design this one as per the 5th percentile popliteal height data, then 5th percentile is comfortable, but 50th percentile and 90th percentile is not comfortable. Similarly, then we will design as per the 50th percentile. If we design as per the 50th percentile, what will happen? As you have designed as per the 50th percentile, so 50th percentile student, his popliteal height is exactly matching, he is sitting comfortably, it is exactly matching with his popliteal height. Now 1/5 percentile students, while 5th percentile student is sitting there, his leg is hanging. So this is designed as per the 50th percentile popliteal height. So 50th percentile student is comfortable, but 5th percentile student, here it is 5th percentile, 5th percentile, 50th percentile, 90th percentile. In this case, while we design as per the 5th percentile popliteal height, then 5th percentile students is comfortable, but 90th percentile, there 50th percentile, there is raised knee, and for 95th percentile there is more raised knee situation. In case of, while you are using 50th percentile data for deciding the leg height, while you are using 50th percentile popliteal height for designing this leg height of the bench, then 50th percentile student is comfortable, but 5th percentile their leg is hanging. And in case of 95th percentile, there is a problem of raised knee. So they are facing the problem of raised knee because this is small in case of them. So they are not comfortable, they are also not comfortable. In the third scenario, if we design the bench height as per the 95th percentile, then what will happen? 95th percentile then 95th percentile student with bigger body dimension, they are sitting comfortably. It is matching with their body dimension, this height. But so they are comfortable. But 50th percentile, their leg is hanging, and 5th percentile, their leg is also hanging. So they are not comfortable. So which percentile data of popliteal height should we use so that most of the students can sit comfortably? So actually answer is 50th percentile. Because in every case, if we use 5th percentile popliteal height data, then 5th percentile students with 5th percentile popliteal height value, he or she is comfortable, but students with higher percentile popliteal value, they are not comfortable. If we use 50th percentile data, then 50th students with 50th percentile popliteal height, he or she is comfortable, and other students around that 50th percentile value, they are maybe comfortable, but students at the lower end, that is 5th percentile or 95th percentile popliteal height value, they are not comfortable. Similarly, while we are using 95th percentile popliteal height value for designing this leg height of the bench, then student with 95th percentile value, 95th percentile popliteal height value, they are comfortable, but for 50th percentile and 5th percentile, their leg is actually hanging. So what should we do to accommodate more number of people, wide range of student? What should we do? We should go for 50th percentile. Why 50th percentile? Because if we use 50th percentile popliteal height value, then what will happen? Good number of students will be accommodated, whose value is nearby 50th percentile, they will be accommodated. If we recall that earlier, the answer is lying here. If we look at the normal distribution curve. So normal distribution curve, if we use 50th percentile data, then most of the students popliteal height value from that mean value or 50th percentile value, most of the students popliteal height value or leg height value will be nearby that value. So good number of students will be able to accommodate that one, because in any population for any body dimension, most of the people for a particular body dimension, more number of people belongs to nearby average value. For that reason, if we design that bench height according to 50th percentile popliteal height, then obviously 50th students with 50th percentile popliteal height, they can sit comfortably, and also students with little bit more popliteal value, say for example up to 60th percentile or 40th percentile, they can also sit with little bit discomfort. But if we use 5th percentile popliteal height for designing that bench, then what will happen? But if we use 5th percentile popliteal height for designing this bench, then only 5th percentile students, their number, students with lower body dimension, lower popliteal height value, their number is less. From the normal distribution curve, we clearly mentioned that if we see the normal distribution curve, more number of people are nearby the mean value, and this mean value is 50th percentile value. But less number of people are there towards 5th percentile or 90th percentile. So more number, from this bell-shaped curve it appears that more number of students popliteal height value is concentrated around the mean value. So if we use 50th percentile popliteal data for this purpose, then good number of students will be accommodated whose value are nearby the mean value or 50th percentile value. But if we use 5th percentile popliteal height, 5th percentile, then only few number of people who are at the lower side, they will be accommodated, but good number of students whose leg height or popliteal height value is more than that 5th percentile, they will not be comfortable to sit. On the other hand, if we use 95th percentile, then 95th percentile at this side in higher percentile value, only few students nearby that, they may be accommodated there, but good number of students whose leg height or popliteal height value is less than the 95th percentile, starting from 95th percentile to 1st percentile, this wide range of students, they will find difficulty to accommodate this, to use this facility. So for this purpose, so what's the final answer? Final answer is we will use 50th percentile popliteal height value for deciding this leg height of the bench, so that 50th percentile students or 50th percentile students with 50th percentile popliteal height value can sit comfortably, and all other students whose popliteal height value is nearby 50th percentile, they will also be able to use that facility, and their number is also big, because as we mentioned from the bell-shaped curve, data in normal distribution pattern is concentrated around the mean value, and as we are moving away from the 50th percentile value, the number of the frequency is gradually, and the number of individual in that side is gradually decreasing. More number of people are concentrated around the mean of 50th percentile value. In both the end, it is gradually reducing. Then what will we do? So we will use 50th percentile for this purpose. Then what will happen for others? In this case, we are using 50th percentile, so now 50th percentile can sit. For 5th percentile or for lower percentile, we will position a footrest. So we will design a footrest. So students with lower popliteal height value, they can sit with lower popliteal height value, they can sit by keeping their leg on the footrest. On the other hand, then what about the 90th percentile? For 90th percentile, we have to suggest them keep their leg forward. So that they can accommodate their leg, they can rest their thighs on the seat and they can extend their leg forward. So this is possible. So instead of raised knee, they can extend their leg in forward direction. So for that purpose, we have to make it sure that there is sufficient space so that leg stretching in forward direction is possible. With the same line, so this forward, another question, so if we consider the sofa, while we are designing the sofa, then what we do, then generally height of the sofa is less. Why? Because it is assumed that while people are sitting on the sofa, their posture will be relaxed posture. While there is relaxed posture and people will, this angle is almost 120 degree or 100 degree, then they will extend their leg forward. So enough height is not required for that purpose, because who is using that sofa, who is sitting on that sofa, he or she will extend his leg forward due to his body bending backward. While this angle, generally it happens, while this angle is coming more than 100 degree, automatically this angle will become 100 degree or 120 degree. Next.